Hello guys, welcome back to Study Sezo. Today in this video we are going to study about logical connectives or simply connectives. Connectives are mainly used to combine two or more prepositions or use it for making compound prepositions. In the previous lecture we have discussed about what is prepositions, examples and their types. We know that we have various types of connectives such as and or negation, biconditional and conditional. These connectives are used to combine two or more prepositions. We have five basic types of connectives. They are negation, conditional, disjunction and exclusive disjunction, conditional and biconditional. Let us go through one by one to understand it better. The first one is negation. Negation is denoted by three symbols, either this or we can use tilde symbol or simply we can use not. We can use any of these three symbols to represent negation. Here, negation is applied on only one statement or preposition. Means we can use only one statement to apply the negation. Let us consider one example. We have this statement P as 4 is a prime number. Let us apply negation to this statement. Negation of P is nothing but negative statement of this statement. Means this is the positive statement, then the negation is the negative of this statement. Means 4 is not a prime number. It means if P is true, then the negation of P is false and vice versa. Let us construct the truth table for the negation. So the truth table of negation is P and negation P. Here we have only one statement. So the total number of possible truth values are 2 power n. Here n is equals to 1. So 2 power 1 is 2. The total number of truth values are 2. They are true and false. We know that if P is true, then the negation of P is false and vice versa. If P is false, the negation of P is true. So the second one is conjunction. Conjunction is denoted by and symbol. Let us see what conjunction is. Consider these two statements P and Q. P is the weather is cloudy and Q is it is raining today. Consider these two statements. Let us apply AND operation to these two statements. First, let us understand what this AND operation is. P conjunction Q reads as P and Q. Here, P and Q returns true when P and Q both are true. Otherwise, it returns false. Now, let us apply AND operation to these two statements. Means the weather is cloudy and it is raining today. This is the AND operation is used to connect these two statements. Let us see the truth table for this conjunction. Here we have two statements. So, the total number of possible truth values are 2 power n. Here n is equals to 2. 2 square is 4. The total number of possible truth values are 4. Let us see what are they. P, Q, P and Q. Let us see the truth value combinations. They are true, false, true, 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 false, false, true, false, false. So when we apply AND operation to these two statements means when both the statements are true, then only it will true. So P is true, Q is true. Then P and Q is true. False otherwise. False otherwise. Here P and Q is the new preposition which is obtained by applying the AND operation. So the third one is disjunction. Disjunction is denoted by the symbol or. It is denoted with the or symbol. Let us understand what the disjunction is. Consider the same example P and Q. These are the two statements. The weather is cloudy and the second statement is it is raining. Let us apply OR operation to these two statements. First, let us understand what OR operation is. Here, P disjunction Q is read as P or Q. Here, P or Q returns true when any one of the statement is true and false otherwise, and it returns false otherwise. So now let us apply OR operation to these two statements. Means P or Q is the weather is cloudy or it is raining. We are using OR connective to combine these two statements. Now let us construct a truth table for the disjunction. Here we have two statements, right? So the total number of possible truth values are 2 power n means 2 power 2 is 4. The total number of possible truth values are 4. Let us see what are they. We have two statements P, Q. We are applying OR operations to these statements. The four combinations are true, 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 false, false, true, false, false. Our statement is P or Q returns true when any one of the statement is true and false otherwise. Means if any one of the statement is true, it returns true. Here we have two. Here in the statement we have false. Both statements consist of false. So false. Here P or Q is the new preposition which is obtained by applying the OR operation. Now let us understand the exclusive disjunction. It is denoted with the symbol this and reads as or but not both same. Consider the same example. Consider the two statements P and Q. Here P as root 2 is an irrational number and Q as 2 plus 3 is equals to 5. Now let us apply the exclusive disjunction to these two statements. It reads as P or Q, but not both. Now apply the exclusive disjunction to these statements, which is root 2 is an irrational number or 2 plus 3 is equals to 5, but not both. Here we have this statement as P or Q but not both. Here the P is root 2 is an irrational number and these two are connected by OR. The Q is 2 plus 3 is equals to 5 but not both. Let us construct the truth table for the exclusive disjunction. So we have this statements PQ and now we are applying P exclusive disjunction Q. Here we have two statements. So the total number of possible truth values are 2 power 2 means 4. The total possible truth values are 4. Let us see what are they. So the combinations are true true, true false, false true, false false. Now let us apply the exclusive disjunction to these two statements. Means either P or Q. Means P or Q, any one statement should be true or false, but not both true or both false. If both true, then the exclusive disjunction becomes false. If both false also, it will become false. Only means P or Q, but not both. So, any one is true, then it will become true. So, the P exclusive disjunction of Q is the new preposition which is obtained by applying the exclusive disjunction operation. So, the fourth one is conditional. It is also known as the implication, which is denoted by arrow mark. It is called conditional. To understand this, let us consider two statements, P and Q. P as it is raining, Q as it is cool. The conditional of these two statements is denoted by P conditional Q, which is read as if P then Q. Let us see conditional operation is P implies Q returns false only when P is true and Q is false. Otherwise, it returns true. Let us construct the truth table for this. Truth table. We have the statements as P and Q. We are applying conditional to these two statements. So here we have two statements. So the total number of possible truth values are 2 power n. Here we have two statements. So 2 power 2 is equals to 4. So 4 possible truth values are there. So let us see what are they. The combinations are true true, true false, false true, false false. Our condition is if P implies Q returns false only when P is true and Q is false. Search for these conditions. When P is true and Q is false, it returns false. So here P is true and Q is false. It returns false. Otherwise, it returns true. So true. Here P implies Q is the output of applying the implication or conditional operation. Now apply the conditional to these two statements. means if P. If it is raining, then it is cool. If it is raining, then it is cool. Our condition is this, right? So, if and P. P is it is raining. Then Q. It is cool. And the last one is biconditional. It is also known as by implication. It is denoted with the symbol like this. To understand this, let me consider these two statements, P and Q. P statement is it is raining. Q statement is it is cool. The biconditional of these two statements is denoted as P biconditional Q, which read as P if and only if Q. P biconditional Q is read as P if and only if Q. Here, P biconditional Q is nothing but P implies Q and Q implies P, which read as conjunction of P implies Q and Q implies P, which can be read as if P then Q and if Q then P. P implies Q returns true when P and Q contains the same truth values. Means P biconditional Q returns true when P and Q, both the statements contains the same truth values. Let us construct the truth tables for the biconditional, which is truth table. Here we have two statements. We know that if two statements are there, 2 power 2 is 4. The total possible combination of truth values are 4. We know we have these two statements as P and Q. We are applying the P biconditional Q. The combinations are true, 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 false, false, true, false, false. Our condition is P biconditional Q returns true when P and Q contain same truth values. Let us search for the truth values which contain same. Here these two statements contain true, true, false, false. So these two truth values returns true. It returns false otherwise. Here P biconditional Q is the new preposition which is obtained by applying the biconditional operation. Now apply the biconditional operations to these two statements, which means P biconditional Q is nothing but if it is raining, then it is cool. And if it is cool, then it is raining. Guys, this is it for now. Thanks for watching. Please do subscribe to the channel.